Okay, start of our last brand new unit, which is crazy. Anyway, so we are going to do our last unit on statistics, and we'll begin today with talking about different types of ways of collecting data. Okay, so like our goal is going to be to collect the data, to analyze the data, and then eventually draw conclusions from the data. And that's what we're going to teach you in these next 5 lessons. So statistics first, okay, it's important that you understand the background. It's the collection, organization, and analysis of data that can be used to draw conclusions, okay? There's different ways, again, of collecting your data, and the thing you're going to have to be careful with if you were ever in a more advanced stats class or using statistics to, draw conclusions, you have to try to avoid bias. So we're going to talk about how bias can affect certain situations. Okay, so let's start with talking about a survey, okay? A survey is a way of learning about a group of people by having some of the people in the group answer questions. Probably a better way of expressing that is to call that a sample survey, where you're surveying a sample of the population, not the entire population of people. So for example, if I wanted to know something about, all the freshmen at St. Anthony's, and I can't get to every single freshman, what I would do is I would ask a sampling of those freshmen, and then I would use that sample to draw conclusions about the larger group. Okay, so in a survey, you basically are just going around asking questions. So it might be a form or some sort of a questionnaire. It could be online. It could be in person, or even answering questions over the phone. Yes, people still talk on the phone sometimes. So that's a survey. You're actually getting out there and interacting with whoever it is that you're analyzing. So here would be an example, like for example in homeroom, if you were asked to give feedback on items for the cafeteria, here's an example of a survey. People would check off, I like it, I don't like it, and then eventually think about it. You would take that data, you would organize that data, and then you would use it to draw conclusions about, should we offer raspberry tea in the cafeteria, or should we take away turkey sandwiches because people don't like them, or something like that. So let's take a look at a second type of survey. Statistical study. It's an observational study. Okay, so even take the word observational. When you observe something, you're just looking at it. That's the key thing with an observational study. Unlike a survey where you're actually interacting with all the people that you're studying, in an observational study, you're specifically not interfering with the people that you're, trying to understand. It might not be people, it might be something else. You would watch, you would record the data you see, and then again, eventually you would draw conclusions from that. Okay, so for example, perfect place for an observational study. Let's say that you are, somebody who's really interested in animals and you want to go study the sleeping habits of lions. You would go and watch the lions. The lions you can't actually interact with and say, hey, lion, how long are you sleeping? No, you would watch how long they sleep, you'd record it in a journal, and then eventually you'd use that to draw conclusions about the lion's sleeping habits. Okay, so far we talked about surveys where you actually ask for input from the population you're studying. Observational studies, you're not interfering, you're just watching and recording data. And then the last one would be an experiment. Okay, so in an experiment, you're going to always have situations where you break people up into specific groups. You're going to give each group what we call a different treatment. Now, that treatment could actually be giving no treatment at all. Like if you've ever heard of a placebo before, sometimes that happens when there's like a drug study. One group gets a placebo, which is like a fake pill. One group gets a real pill, and then they look at the outcomes, or the results of those two groups and see, is it drastically different when the person has the actual treatment as opposed to having no treatment at all? Okay, so that's the thing with an experiment. You're actually controlling the situation and you're breaking up into groups. Okay, the treatment is what is provided and the response is the outcome that you see in each specific group. And I will talk eventually about how you can test the effectiveness of those groups. So we're going to look at a couple of situations and we're going to talk about what's going to be the best kind of statistical study to do in each of these situations. A sample survey, again, where you're asking a selected group of the entire population you're trying to study, you're interacting with them. An observational study where you are just watching and recording. Or are you actually fully interacting and controlling the situation? Okay. So again, we're just identifying what's happening in each situation. A pharmaceutical company is interested in comparing 3 brands of pain relievers. The company wants to know if one brand is much better than the other brands in terms of mobility improvement. 3 different groups of 30 people participate in the study. Each group gets one of the 3 brands of pain relievers. The improvement in mobility of these 90 people is recorded after 5 weeks of taking the medicine. So notice how they're talking about groups and how each group gets a different brand of pain reliever. The fact that you have 3 groups getting different treatments is exactly why we would refer to this as an experiment. I would say anytime you're talking about the effectiveness of some sort of a drug or something like that, that's probably an experiment. Okay, number 2. Medical records of a group of longtime residents of a town are compared to the medical records of a group of longtime residents of another town. Researchers are curious to see if one town appears to be quote-unquote healthier in general. So you have to think about it. Are you actually asking people for input? It doesn't look like it. It looks like they're just looking at the records. Are you interacting with the people? Are you just watching from afar? Or are you breaking them into groups? We're more kind of watching from afar here. You're not actually going person by person to ask for their health standards. You're just looking at the records that were previously recorded. So probably the best thing for this would be an observational study. Okay, you don't even have to actually know the people's names. You could just look at their data, organize it, draw conclusions from it, and see if one group is healthier than the other. Number 3, a group of 600 registered voters in a given county are asked how they intend to vote in an upcoming election. A summary of their responses is posted on a news website, and it is implied that this group is representative of all registered voters in that county. Okay, so notice how you're asking a smaller group than the full population and using that to understand things about the full population. That's exactly what we refer to as a sample. The fact that you're asking for input, that's an exact version of what we would refer to as a sample survey. Okay, so here's our 3 situations so far. You're breaking things into groups, you're watching from afar, you're asking for input. Okay, take a look at the last one. In a study to see if administering a medication orally or by injection makes a difference in how quickly people with back pain feel relief, a group of 400 adults suffering from back pain is divided into 2 groups. That's your key right there. Divided into groups, and you're looking at the effectiveness of some sort of back pain relief. Okay? So that's a perfect example of an experiment because you're breaking into groups and giving each group a different treatment. So when it comes to doing a proper statistical study, it's extremely important to include randomization, okay? Random people, random assignment, whatever it is. I'm going to talk about that in a second. Without randomness, you can create bias, which will skew the results of your study. So meaning that your results will not actually be valid results, so the conclusions you draw aren't really important, okay? So when it comes to doing a survey or an observational study, it's important that you employ what we call random selection. Select the people who you are studying, whether it's in the survey or the observational study, at random. Okay, you want to try to avoid there being bias. So a perfect example, let's say you were studying something about what to do with, future budget money at school. Would you only ask the football team? No, because obviously they're going to use it towards football. Are you only going to ask the band? No, because they're probably going to use it towards the band. Isn't it better to ask like every 5th person coming in the building or every 5th person in the cafeteria? That way you get a sampling of the full population, okay? You want them to be impartially selected, which means you're not picking people yourself. You're creating some sort of system that randomly picks people, and that's the way to get the best, least biased results. When you're working in an experiment, you want to employ what we call random assignment. When you break up those people into 2 groups or 3 groups, you want to impartially assign people to each group. If you are saying, all the boys go in one group, all the girls go in another group, if you're more intentional like that, you're not going to get accurate results from that study because boys might respond different than girls do to whatever treatment that you're doing or whatever it happens to be that you're studying. So the 4 studies that we had mentioned before, I'm adding a little something, and I want you to figure out what's the issue with that extra line, okay? Like, how is that going to affect, the study itself? So we're looking again at those 3 pain relievers, okay? So it's an experiment. It says 3 different groups of 30 people are in the study. Each group gets one of these pain relievers. Okay, the first group of 30 patients were the patients of Dr. Smith. The second group were the patients of Dr. Jones. The third group was the patients of Dr. McGillicuddy. What's the problem with the way that these people were selected? The answer is that they didn't use random assignment, okay? So you need to use random assignment, meaning that your people can come from Dr. Smith, Dr. Jones, and Dr. McGillicuddy, but you can't give one treatment to one group and one treatment to another group and one treatment to a third group without mixing them all together, getting a sampling of people from Smith, Jones, and McGillicuddy that get the first pill, and then a sampling that get the second pill, and a sampling that get the third pill. You need it to be random assignment, okay? Because you never know. Maybe Dr. Smith has all old people. Dr. Jones has all children. Obviously, old people and children are not going to respond the same way to medicines and pain relievers, okay? Take a look at number 2. Medical records in a group of longtime residents of a town are compared, okay? So again, we're doing that observational study. So look at the last sentence. In order to save time and money, all of the records were selected from the largest of 4 hospitals in town X and the largest of 3 hospitals in town Y. What's the issue with this situation? We need to use, okay, random selection. Okay, as I had mentioned up in the top. We can't, introduce favoritism. Like what if the largest of the 4 hospitals in each county are the richest people in those counties? Those people's health is not going to be the same as people who are in more poverty-stricken areas. So you need to be representing the entire population if you're trying to draw conclusions about the entire population. And again, that's the whole purpose of random selection. Okay, so one last one. A group of 600 registered voters in a given county are asked how they intend to vote in an upcoming election. So these people, it says the summary of their responses is posted on a website, and it is implied that this group is representative of all voters. The 600 voters submitted their opinions via a web page and were able to choose to participate after seeing an advertisement on television. Okay? That's actually the problem in this situation. When you are working with a survey, again, you need to employ random selection. You need to actually select people to respond to the survey, not wait for them to call in. Why? Well, because usually it's people with the strongest opinions that volunteer their opinion. Whether it's one direction or another, you want to be representing the entire population, and those people in the middle are probably unlikely to call in. Not to mention, if you're using a web page, how do you know that every single person will know how to use that web page? You're being biased against people who maybe don't have a computer or have technology or don't have the tech skills, and therefore, again, you're not representing the entire population. So once more, you need to employ random selection. Okay, so again, recap, 3 kinds of statistical studies, say that 10 times fast. Surveys where you're asking for input, observational studies where you're just observing from afar and not interacting, an experiment where you're actually taking a group, breaking it into multiple groups, and studying what happens when you provide different treatments. And again, it's very important to make sure that there is not bias in the way that you're creating your